Well, students, I'm present here again with my one more video. This video will be concerned with vectors, and as you know, vector is a very important part of mathematics and also physics, and you have been studying this topic particularly in physics, but it is mainly the part of mathematics, and mathematics before vectors and mathematics after vectors. It is completely different, and particularly in the three-dimensional geometry, in the beginning we were using Cartesian method to discuss all our problems, but after the arrival of vector, the treatment got changed, and we call all the new analysis by vector treatment. Okay, so now we study three-dimensional geometry and also the questions of plane geometry by vector method, and it gives us a very smooth and easy solution. So today we are beginning what is the meaning of vector. Okay, students, vector, in fact, it is related with measurement. Okay, so measurement, when we go for measurement, then we must know that which quantities should be measured or can be measured. Okay, so the quantities which can be measured are called physical quantities. Okay, physical quantities. Now these physical quantities they are of two types. We can measure only the physical quantities, and I will explain what do you mean by this term physical quantity. But before that, you should know here that when we go for measurement, we come across two situations. First, the physical quantities having only magnitudes, and quantities having magnitude and direction. Okay. So these two types of physical quantities can be measured. I can give you some example here. Mass, then time, okay, distance, speed. Okay, so lot of quantities are of this type. So here you find that when you go for the measurement of such quantities, mass, time, distance, this is distance, speed, etc. We need only the magnitude of the physical quantity, and then we can go for its unit and measurement. Okay, but few quantities are of this type also, in which we find magnitude and direction both are concerned. For example, force, okay, displacement, then we have acceleration, etc. So to measure these quantities, we must know their magnitude as well as direction. Okay. So vectors are related with this type of measurement, in which we have direction and magnitude both. So these quantities are called Scalars means physical quantities having only magnitude, and these quantities are called vectors. Okay. So finally we get the definition of vector, that those physical quantities which have direction as well as magnitude are called vectors. Okay. And those physical quantities which have only magnitude, they are called scalar quantities. Okay. Now how to represent vectors. Okay. So for that, it is representation of vectors suppose I draw a line L. Okay, L is a line in which if I take 2 points AB, okay, there are any 2 points on the line L. Now this line segment AB is called a line segment. This line segment may have two directions, one from A to B and another from B to A. Okay, so this line segment may have two directions. First from A to B, and second from B to A. Okay. From B to A. From B to A. So A to B is represented by this way. Okay, it is from A to B. The arrow says that the line segment is beginning from A and is ending in B, and similarly B to A is represented by BA. Okay. Now what is the meaning of this discussion? That a vector quantity is represented by a directed line segment. One more characteristic we find for the line segment, it has definite length. The distance from A to B is called length of this directed line segment. So the length of AB and BA may be same, but since their directions are different, so we call them as different line segments. So a vector is represented by a directed line segment. That means it has two properties, first direction and second magnitude. Okay. Now we can conclude here that a vector is represented by or directed line segment. Now coming back to the previous diagram, in which we have taken one line L and 2 points on it A, B. And we say that AB is a vector. So what characteristics we find here? Of a vector. First, it has a magnitude. It has a length. In our discussion, the vector is AB. Okay, so it has a length which is called magnitude. This is the first characteristic. Second, it has a direction, also called sense. It has a direction, as you find here, it is from A to B, and it has a support, which is L, because every vector can be taken as a part of a line, so it has a support L. Okay, so what we find is that when we go for any vector and its representation, we get three characteristics there. First, it has a length, that is magnitude, and then it has direction, sense, and then it has a support, which is the L, whose part is this line segment AB. Okay. Now, in the representation of this vector, we call A as initial point, initial point means the point from where the vector begins, okay, and B is called the terminal point. B is called the terminal point. Okay. Now, immediately after this, one of the type of vector comes here, which is called zero vector. What is the meaning of zero vector? And whenever we'll discuss any type of vector, we will discuss in terms of its three characteristics, that is magnitude, direction, and support. Okay. Zero vector. A vector with zero magnitude is called a zero vector. Okay. So magnitude is zero. That means what will be the situation in which magnitude is zero? When it does not have any length. Okay. So no length means the initial point and terminal point must coincide. Okay. So for zero vector, initial point and terminal point coincide, and therefore we can say that AA, BB represent zero vector. Now what about the direction of zero vector? Okay, so in fact its direction can be any direction. Okay, so magnitudes 0, direction it can be any direction. And what about its support? Any line may be taken as the support of a zero vector. Okay, so we have discussed here zero vector in terms of all the three characteristics. It has no magnitude, it can have any direction, and third is any line can be its support. Okay, next, the meaning of equality of vectors. Okay, so again we have to discuss this term in terms of magnitude, direction and support. Two vectors A and B are said to be equal if first their magnitudes are equal, second they have the same direction, or sense, both are same thing, and third they have the same or parallel support. Okay, so again we have discussed this definition in terms of three characteristics of vector, in terms of magnitude, direction and as well as support. Okay, so I will explain what is the meaning of all these three. Suppose I take the support as L and I take suppose AB 2 points and then CD also 2 more points, such that length of AB is equal to length of CD and they have the same direction. AB and CD have the same direction and again AB and CD have the same support. Okay, and that support is L. So under these three conditions, we say that the vector AB is equal to vector CD. Okay. So we have discussed in terms of all the three characteristics of the vector. So when two vectors are equal, their magnitude must be equal, their direction should be equal, and they may have the same support. Now let us discuss in terms of parallel support. Another situation, because in the definition you find the term that they may have parallel support. So if I take L and M as two parallel lines, and if I take AB here and PQ on this with the same direction. Okay. So if the length of AB is also written as magnitude. Okay. If length of AB is equal to length of PQ, second, AB and PQ have the same direction, and third observation, that they have parallel supports. L and M. Then we say that AB is equal to PQ. So you will get a lot of questions in which equality of vectors is concerned. So you have to think in terms of these three criteria. Okay. Now next is unit vector. Unit vector. A vector is said to be a unit vector when its magnitude is unity, that is one unit. Unity. Okay. A vector is said to be a unit vector when its magnitude is unity, that is one unit. Okay. So if A cap is a unit vector, then its magnitude is 1. The magnitude of a vector is represented by the vector inside the parallel line. Okay, so this is the representation of magnitude. So if A cap is a unit vector, then its magnitude is 1. Now, how to get unit vector? When we divide a vector by its magnitude, we get a unit vector in the direction of the given vector. Okay. So unit vector, when we divide a vector by its magnitude, we get a unit vector in the direction of the given vector. So unit vector in the direction of A is A cap, and this is the vector divided by its magnitude. Okay. After that we have collinear vectors. What is the meaning of collinear vectors? Two or more vectors are said to be collinear vectors if they have the same or parallel support. Okay. Now in terms of support we have discussed. What in terms of the magnitude? The collinear vectors may have any magnitude okay. So in terms of support we have discussed here. Again, in terms of magnitude, I've just written here that collinear vectors may have any magnitude, and third, their direction. Their direction may be same or opposite. Okay. Collinear vectors are also called parallel vectors. Okay. Vectors. Now I can give you an example here that if L is a line in which CD, and then let us have PQ also. Suppose the direction of PQ is this way, direction of PB is this, direction of CD is this. Now since PQ, BA, CD have the same support, hence they are collinear or parallel vectors. Now another situation, if suppose the supports are parallel, one is L, another is M, and if I take AB and PQ, suppose direction of AB is this and direction of QR is this. So if L is parallel to M, means if the supports are parallel, then AB, PQ and this is QP and QR. Okay, this point is R. Or collinear or parallel vectors. in the collinear vectors or parallel vectors, direction may be different, as you find here. Direction of AB and QP, they are opposite to each other, still they are collinear vectors. Okay. Now next, co-initial vectors. So before that, we can say that the vectors which are not collinear are called non-collinear vectors. Okay, and after that, next type is co-initial vectors. To discuss these vectors, let us draw this type of vector. So we find that vectors AB, AC, AD have the same initial point. Therefore, they are called co-initial vectors. Okay. After that, we have next term, coterminous. Coterminous vectors. So again, one vector is, suppose, the direction is this way. So since the vectors AB, CB and DB have the same terminal point B, so they are called coterminous vector. Okay. Then we have negative of a vector. A vector B is said to be negative of the vector A when there are two conditions here. The magnitude of A and B should be the same, and the direction should be opposite to each other. Okay, and they should have the same support. If you want to add, they should have the same support. Okay, and it is written as minus a, that is b is equal to minus a. Next, free vector. What is the meaning of free vector? Okay, this is a very important discussion because in most of the questions when you solve, we shift the given vector passing through the origin all the time. So we take the vectors as free vectors, and what is the definition here? Suppose AB is a given vector. If AB is a given vector, now if we shift this vector in parallel way without changing the direction, okay, AB is shifted to the new position PQ without changing the direction and without changing the magnitude, means the length of AB is same as length of PQ, or it may be shifted, suppose in this way, and if I take the point as CD, so again if the magnitude of CD is same as AB and direction is also same, then what we find here that the vector AB is subjected to the parallel shift, and hence it is called a free vector. But whenever we shift any vector, we take into account that direction and magnitude should not change. Okay, so we call such vectors as free vectors. So a vector is said to be a free vector when it may be subjected to parallel shift without changing its magnitude and direction. Okay. Now, immediately after comes localized vector. Localized vector. Now we have one restriction. If you compare it with free vector, that suppose AB is a given vector and P is a given point. This is given and P is also given. P is a fixed point. Okay. Now if we shift this vector parallelly and equal in magnitude, passing through a vector, suppose we shift AB parallelly in this direction the direction of PQ such that P is a fixed point and the magnitude of PQ is same as AB. So we call AB as localized vector because it has been shifted parallelly through a given fixed point P. Okay. So if AB is a given vector and P is a given point, then a vector PQ such that PQ is equal to AB. Okay. If AB is a given vector and P is a given point such that PQ is equal to AB, that means these two vectors are equal. Equal means they have the same direction and magnitude. Then AB is called localized vector. Okay. Then we have very small definition here, proper vector. A vector or non-zero vectors. Non-zero vectors are called proper vectors. Okay. Then coplanar vectors. Two or more vectors are said to be coplanar vectors if they lie in the same plane or they are parallel to the same plane. Okay? Two or more vectors are said to be coplanar vectors if they lie in the same plane or they are parallel to the same plane. Okay. Then reciprocal of a vector of a vector so this is again important definition. What is the meaning of reciprocal of a vector? A vector B is said to be the reciprocal of the vector A if magnitude of B is reciprocal of magnitude of A and direction of A and B are the same. Okay. Now reciprocal is represented by reciprocal vector of A is represented by A, okay. So B is equal to A inverse, and as you have seen there, that if magnitude of A is suppose lambda, then magnitude of A inverse is 1 by lambda. But the direction of both vectors are the same. Okay. Now there are two more definitions. One is like and second unlike vectors. Okay, like and unlike vectors. So vectors having same direction are called like vectors. Magnitudes may be different. Okay, and also line of support may be also different. And similarly, vectors having opposite direction, they are called unlike vectors. They may have any magnitude or they may have any support. Okay. So students, this is the end of this video, and in the next video I will cover up some more concepts of vectors. So that will be the next video. Thank you very much.